All right, boys and girls, we're going to go back to functions. Trig is not going away. You're still going to need to know all that stuff, but we're going to end up doing a lot more with functions, and so we need to be sure that we're all kind of on the same page. So feel free to pause and write stuff down. This is going to go pretty quick because it's probably the fifth or sixth time that you've been given this information. So I would say 99.5% of this is going to be review. First thing, a function is defined as a relation in which the independent values do not repeat. So x's don't repeat. Whatever the x value is, whether it's time or any of that stuff, for it to be a function, the x's cannot repeat. There's various ways to represent a function. You can do a graph, you can do an equation, tables, word problem with description, a model, any of that stuff. Let's go to my t-chart right here. I got x and f of x. Hopefully by now f of x, or you figured out f of x is the same thing as y. So for our x's, we got domain, input, independent, x, and then the cause. And then f of x, range, output, dependent, y, and the effect. I think we're good on that. We'll jump on to vertical line test. Vertical line test is that test that we can do on a graph to tell whether something is a function or not. Doesn't work on an equation, doesn't work on a table. It only works on a picture. So if it only hits it one time, like this guy does right there, then it is a function. If it hits it more than once, so on my circle, hits it once there and once there, it is not a function. It's just a relation, but not necessarily a function. So like if we go back to our conic sections, an ellipse is not a function. A circle is not a function. Vertical hyperbolas, that was there and then there. Remember those? Those are not functions either. And then horizontal hyperbolas actually aren't functions either. The only ones that are a connection section that was a function was a parabola, and that would have to be vertical. Okay, so vertical line test, we're good on that. Next thing is input and output. We've already gone over that. That's another word for x's and y's. An equation is another way to write a function rule. So for a, b, and c here, value of f of x when x is 2, fancy way of saying that, a very shortcut, is find y when x is 2. So we're just going to plug 2 in. Oops, sorry. Just going to plug 2 in. So 2 there, 2 there. So I get 9 minus 6 plus 5. So that is going to give me 9 minus 6 is 3. I made a mistake somewhere because that's 4. Cool. So 4 plus 5, 9 minus 6 is 3. Awesome. Cool, cool, cool. When you have f of a, just take a and put it in. So a squared minus 3a plus 5. And that's it. And then the last thing is when you have x minus 2, just take x minus 2 and put it in. So you got x minus 2 squared minus 3 times x minus 2 plus 5. So then we're going to multiply, do all that stuff. So I get x squared minus 4x plus 4 minus 3x plus 6 plus 5. Combine the like terms, so you get x squared minus 7x plus 15. I can't write 15. 15. All right, so that was probably the hardest one as far as maybe FOIL, box method, any of that, double distribute, whatever you want to call it. The last thing is domain and range. Go ahead and pause it, write it down, and then start it whenever you're ready. What's up? All right, so let's go over domain. Domain is x values. So whenever we're talking about domain, we always go left to right. So if you learn like Dolar, Ribbits, or Rabbits, or whatever in Algebra 1, that's awesome. If not, just remember least to greatest. So anytime you have a quadratic, a linear, or absolute value function, you're going to have a domain of all real numbers or negative infinity to positive infinity. So for a, it's a quadratic, so that means my domain is negative infinity to positive infinity, or another way to say that is are all real numbers. Letter B is an example of a rational. So here I have a little note about our domain being when our denominator can't equal 0. So what number makes our denominator 0? The answer is 7. So that means it's going to be all real numbers except x cannot be 7. You could also say from negative infinity to 7 union 7 to infinity. If you want to say that, that's fine. Anytime the denominator gets us to 0, we get an undefined picture. It's a whole or an asymptote depending on your equation. So as far as that goes, that means that we can't divide by 0. That's why it's undefined. So that's why we can't have 7 there. And then lastly, letter C. Uh, Anytime the radicand is less than 0, it's imaginary. So we want stuff bigger than either 0 or bigger than 0. So what we do is we just set the inside part equal to 0. I get -3, so my -3. So everything bigger than or equal to -3 is my answer. If I put -10 in here, I get -7, which I can't take the square root of -7. I mean, I can. It would be, I square root of 7, but I can't graph that. Since we're talking about domain and range, we're always talking about graphing as far as this goes. That's it, guys. Good luck. See you later.